So welcome. My name is Joey Gonzalez, what people call me here. I am an associate professor in computer science. I am now recently the vice chair of the Undergraduate Studies Committee, so I deal with a lot of the undergraduate matters. This is the Computer Science Information Session. And today we'll talk about the computer science major, which is in CDSS. I should start with congratulations. It is a big deal this year to get into computer science. I want to congratulate all the students. We had a much more selective threshold for computer science for the first time. It was a tough year to get into computer science, and you all did amazingly well. I also want to congratulate the parents. I have 2 kids, and I don't know how you did it. My oldest is in kindergarten, and that's already a lot of work. So well done. Congratulations, everyone. Okay. So a little bit about me. So I'll talk about me, and then we'll go into the major. So as I said, I'm a faculty in computer science. I'm one of the directors of the LMSys organization at UC Berkeley, which is kind of pioneering work in generative AI, large language models. I also run the Sky Computing Lab, which is transforming how we do cloud computing. So I do a lot of work in big technologies. Research, generative AI systems, and I'll talk throughout today about getting involved in research. That's one of the important and exciting things you can do at Berkeley. It's a critical part of our program. Teaching. I teach the data science classes, and I will soon be teaching some of the upper-div AI classes as well. I already teach the graduate level classes. I often teach in this lecture hall, so I deal with big audiences, and this is what the biggest classes at Berkeley look like. Sadly, this is also what the biggest classes at Berkeley look like about halfway through the semester. This is the attendance we get because it's on Zoom. And this is for the intro classes, which is good because then I go to office hours and I get a chance to interact with the students directly. So we have other mechanisms of interacting, but again, this is what a big class at Berkeley feels like. So I teach the big classes. I also teach graduate seminars in AI focused on the kind of AI systems, so again, more on the research side. Entrepreneurship is very big at Berkeley, maybe bigger than some other schools in the South Bay. I've been involved in 2 startups, or currently involved in 2 startups, or finished one, starting another. A lot of the students, undergrad and graduate students and faculty, get involved in some form of entrepreneurship or another throughout their time at Berkeley. So it's a great place to get involved in technology shaping the field. A little bit about my background. So I was an undergrad at Caltech, which is like Berkeley, but the exact opposite on scale, so a much smaller school. But same kind of passion for research and science. The smaller scale had advantages and has disadvantages, and I can talk to those today as well. I did my PhD at Carnegie Mellon, flew all the way across the country. I can now say definitively that I will stay on the West Coast. I enjoy the life here, the research here, and the climate here. Unfortunately, you got to see the worst day in the past week, which is today, so poor timing on the weather's front, but yeah, so generally a great place to live, and I can talk, as people want at the end, about kind of trade-offs between where I've been in my academic career. I want to comment on why I chose Berkeley. Faculty have a choice. Berkeley faculty often have a lot of choices of where they want to go. I chose Berkeley for 2 reasons: impact and community. No slides for these. So impact first. We do really exciting research here. Some of the foundational research in computer science was done at UC Berkeley, all the way from the chips you use in your phones, we recently got a Turing Award for that, to Unix, to the platforms we use for the web every single day. Funny thing, so this slide, the right side of this slide here, this is all stuff from the recent time, right? These are all projects that came out in the past 5 or so years. One of the things that I think is unique and special about Berkeley is we don't just write papers. We don't just graduate students. We build things. We build big open source projects that are used throughout computing today. Projects like Apache Spark have built billion-dollar industries around them. Caffe was what Meta, Facebook became their kind of core system for serving models. ChatGPT, the core technology behind that was developed here at Berkeley. So things you might have heard of. RISC-V is kind of the future of computer architectures. A lot of these things are coming from my group right now, changing the space of generative AI So a lot of really cool stuff is happening at Berkeley, and a lot of that is not just papers, but actually building things that the world uses. A lot of the top faculty at other schools, if you're considering another school, you're likely working with a Berkeley faculty, or Berkeley alumni. So someone from Berkeley is probably the faculty you'll encounter at most of the top schools in computer science. Our PhD program puts out some of the best students and then best faculty in the world. And then for entrepreneurs, I said Berkeley has a pretty strong entrepreneurial scene. There is significant entrepreneurship, especially in computer science. I know this other school you might have heard of in the South Bay is higher on the list, but if we just focus on CS, Cal would be at the top. So the big technologies coming out in computer science are coming out of, big companies are coming out of Cal. So good entrepreneurship. Doesn't mean everyone has to be an entrepreneur, but we do that well here. And then community. Berkeley's big, but you build your community at Berkeley. This is my lab, my students, many of which were undergrads. They went on to do PhDs with me. Some of my other undergrads in our various poster sessions at our retreats, and my now 5-year-old daughter, right? This is my community. I like Berkeley because I get a chance to work with people from very different interests, very different backgrounds, both in computer science and outside of computer science. I've had people from the law school say, hey, Joey, that model you're working on, you need to work on that license for that model a bit more carefully. And I've had collaborations with people in chemistry. We're building materials to save the planet because that's what we have to work on, taking AI to solve important problems that face mankind. And I can do that here at Berkeley because I have such a big community to draw from. So for me, impact and community. And hopefully for you, too. Those are the things that you're maybe thinking about in your careers. All right, so that's me. Now I'm supposed to talk about CS at Cal. And I thought, to make it interactive, I'd first get what you want to hear about, or maybe what you're thinking about for CS at Cal. So again, let's try this. You should be able to go here, and you should be able to fill in a poll. Let's see if it works. Type away. It should be showing up. Did I do it wrong? Research, wonderful. Okay, someone press enter. We'll talk about research, definitely. No other, oh, there we go. Job opportunities, major versus minor, research, nice. Internships, good, we could talk about that. Misconceptions about CS, that's good, we could talk about that. Job opportunities. Give you one more minute to answer. Software engineering, diversity issues, quantum information sciences, big focus now. Cybersecurity, big focus. Safety. Okay, focus on math. So a lot of good questions. Questions about the technical aspects of the program. Also questions about the kind of procedural aspects. I'm pretty good at the technical aspects. I am okay at the procedural aspects. So as I said earlier, we have the staff here that actually know all the procedural aspects and can give you really clear answers to more concrete questions about how do I do X. And you can ask questions in the slide right now, and they will try to answer them. If they don't get a chance to, I will try to answer them in the Q&A at the end. Okay? All right. So we'll start at the high level. So CS is now in the College of Computing, Data Science, and Society. So we have moved out of, in fact, it was previously in L and S, L and S, the letters and sciences, and that we've now moved into the College of Computing, Data Science, and Society. We also, the CS curriculum is closely connected to the EECS curriculum, which lives in the College of Engineering. This is the Dean of the College of Engineering, so Sujay. And Jennifer Chase is our new dean for CS and for CDSS. That's the leadership. We have 2 leaders, which is exciting. And one of the things that we're trying to do as part of this dual leadership program is have more resources, getting more budget, getting more support for our program so we can grow our classes and better support our students. So 2 leaders. We have department leadership, so EECS, the EECS department, which now lives in 2 colleges. It's a little weird, but we do. We have a chair that runs the whole department. And then we have an E chair for E-oriented stuff, a CS division chair. And then we have me over here on the right, in the web. And I'm just a vice chair of the Undergraduate Matters Committee, but I talk and deal with a lot of the stuff associated with undergraduate studies. So leadership for our department. Our mission at Berkeley is first, to create knowledge. We push fundamental knowledge as well as technologies. I say we build stuff. And we really pride ourselves on interdisciplinary collaboration. That can be in the small, across areas of computing, to in the large, across campus. I'm now involved in setting regulatory policies for the state of California for generative AI. So I'm now learning about law, which I know very little about and trying to get up to speed on. So a chance to work across a broad campus with many different disciplines. We want to educate future leaders. And that is why you get a broad education in CS here. It's not just about being an engineer, but understanding the consequences of what we build and being able to participate and lead in the development of the field. Right? So that means some of you might become professors. Some of you might take better paying jobs in industry or entrepreneurship, and some of you might go on to affect policies in the government. Right? And we want to give you the skills to work in all of these settings. And in CDSS, we have this goal of serving society. It's another pillar of our work. The curriculum in CDSS has been updated to really reflect this. We now have a requirement for this reasoning about social good, the societal and ethical implications of technology, as a core requirement in the CDSS college and all majors inside of it. Right? So really focusing on the awareness. And we try to connect that locally to issues around Berkeley, nationally, around the country, and internationally. Okay? It's a big mission. Reputation. So I don't really put a lot of focus on these, but let's go ahead and talk about them. There are entities that rank schools. We can look at both the undergraduate and graduate rankings, undergrad and graduate rankings. We're currently in number 2 in computer science at the undergraduate level. I don't know how to properly quantify that. I don't know if you should read too much into it, but Berkeley is one of the top schools in computer science. It's also one of the top schools in electrical engineering and computer science, so the whole area is covered. Where I can think a little bit more, in the graduate program, we are number 1. The best place to do research in the world for computing. And I know that because we recruit the best faculty in the world and the best students in the world. And they consistently come here for their graduate studies. So cutting edge research is done here at Berkeley in computer science. So that I can say with confidence. And we're just behind in number 2 for electrical engineering. So very strong programs. And I think this part here, having one of the best graduate programs, has the effect that we get the very best faculty in the world, the very best graduate students, which participate in both the research and teaching. And it allows our community to really empower the creation and dissemination of knowledge. So we have the best people in the world, the strongest community. Faculty awards. Our faculty are great. As I said, we recruit the best in the world. This is just a sampling of the faculty awards. I don't have an award on this page, but I'll work for it someday. We have quite a few Turing Awards. So Turing Award's sort of the Nobel Prize in computing. It's the highest honor that you can get in computing. And we consistently keep getting them, so we're doing well in computer science. Also, many of the major engineering society awards go to faculty at Berkeley. We have a big community. I've said this a couple times. Let me just actually give you the numbers. So we have about 100 regular faculty members in computer science. I say about because faculty graduate, that is to say retire. We have new faculty coming in all the time. We have some faculty going on leave to launch companies, to take sabbaticals. So about 100 is our kind of floating state faculty in computer science. We have 30 plus emeriti faculty. Many of the emeriti faculty don't leave. They come in. They're involved in research today. They advise people. They're just not officially teaching classes. So some of the Turing Award people will still be around, and you can work with them. We have about 750 graduate students. So a pretty big graduate program. Okay. So 550 in the PhD program alone. It's one of the, as I said, the top PhD programs in the world. We have about 200 professional masters, and we have a fifth-year master's program that will be important to you all, which is a way to do a master's in 1 year at Berkeley. We have a lot of undergraduates in EECS declared. And this historically has been an issue. It got big. And we've been trying to bring the undergraduate program in CS down to reduce competition among students, to make courses and faculty more accessible. And as a consequence, this year we admitted 150? Is that right? We admitted 150 people in CS. And you are guaranteed to be in CS if you're in that 150. In the past, we admit about 1,000 in previous years. Yeah, so in previous years, we admit about 1,000. So 10x-ish reduction in the number of students admitted. Why? Because we don't want people fighting for slots in classes. We want to make the classes more approachable. We want everyone to have a chance to enjoy the program and to work with faculty. So you are lucky, as I said earlier, to make it into that pool, and you have a unique opportunity to be in a much smaller environment for you. There will be students in the upper classes that are still big, but as they graduate, the program will get increasingly smaller. Okay? $2,000 in computer science and EECS. So again, these numbers reflect the old trends. Is this the first year, I think, that we've switched to 150? Second year. So we're already starting to shrink things down. Let me stop here. Are there questions that people have? It's often a concern for people. There are a lot of questions on the poll. Are there any questions in the poll that we need to answer?
Lots of
AP questions. Okay. Let me keep going. We'll get back to AP when I start talking about the curriculum, and you guys can answer. Wait, one more time? Double majoring questions. All right. Well, I'll talk to the curriculum and you can answer those questions. Any questions so far about this stuff? Yeah.
When do they have to start applying for the fifth-year master's degree?
All right. So let me get to the curriculum and we'll go through that. That's a good question. So when to start the fifth-year master's, I'll talk about that in a moment. So maybe I'll keep going. We'll come back to these questions. EECS and CS are spread all over campus, as I said earlier. Maybe I didn't say that. So yes, our program is spread all over campus. We have multiple buildings that cover different areas of computing. Computer science largely is in Soda Hall. Where's Soda? Here. So that's the building way over that way. You should visit it. We have AI has bought the top floor of this building, so a lot of the AI research is over there. But the good news is, in the very near future, we're going to have a brand new building. And hopefully in the next year or two, actually. So you might have seen a giant construction site on campus. This will be the new Gateway building. It's a beautiful building full of windows, which will be interesting when the sun is blaring, but it's going to be a giant open space. And again, it's designed with this idea of community to make it so you can see people across the window, across the corridor, and build that community. And we'll have multiple people in there. It'll be statistics, computer science, some economics, and other areas as well. We'll have homes in this new building. It's a new CDSS building. Research areas. E and CS are very closely connected at Berkeley. To a first approximation, this is a simple drawing, a diagram of kind of the differences between the CS and EE programs and where they overlap. Much of the coursework I do or teach over is on this side, so the CS side. I'm guessing there's a lot of interest in artificial intelligence, but then we do some of the work in control and robotics on the EE side. For you all, it won't really matter. The classes will be both EE and CS classes. You'll have people from both areas, from EECS and from CS in your classes. Maybe the one thing to note is it is a strength that we have a strong device physics component to our program. Okay. So if that's something that interests you, those might be classes you might end up taking. Things that look at integrated circuits. In fact, some of the core curriculum touches on the hardware side of computing. I said I came to Berkeley because I wanted that community. One part of that community is we are not just the best computer science program, but we have one of the best civil engineering programs, one of the best economics programs, one of the best psychology programs, biology, history, sociology. Electrical engineering, second, that's good. We said CS is second. we'll get up there. Chemistry, I'm working closely with chemistry. Math, statistics. We have many of the almost best or best programs in the world. This is looking at undergrad. In many cases, the graduate programs at these sub-areas are in fact the best. So it is a chance to work across an entire campus, not just to do computer science in the lens of just a single computer or just in computing as a whole, but thinking of how that interacts with other disciplines. So I said there are two programs. So there's a EECS, it's a BS in EECS. This is run by the College of Engineering. And then what you all are here for is the BA in CS. This is run by the new College of Computing, Data Science, and Society. To a first approximation, the big difference is that the EECS program has a slightly strong emphasis on physics, and maybe on math, maybe. And the CS program has a slightly strong emphasis on humanities and social sciences. You can still take physics if you want to, but you don't have to. In the old days, students would do this because they didn't want to take that physics class, so they would switch over here. You can't do that easily anymore. The CS program provides a more broader view of computing, so it connects to other parts of campus, as I said earlier, and tries to be a more holistic approach. Both programs are great. And I think maybe this is the most important point. From the coursework perspective, it's essentially the same. And I actually have the coursework now, so let's build this out. This is a picture of the curriculum for the CS major. There is a broad lower division, which consists of this 5-part series. And I'll talk through each of these classes in a moment. This is the CS 61 series. This is sort of an overview of the big parts of computer science, some kind of abstractions and programming to kind of algorithms and data structures. We'll do a second. And then kind of systems and hardware. You can't read my writing. It's OK. I'll show you on the next slide. In fact, I'll get rid of it. It's embarrassing. CS 70, this class is kind of discrete algebra, or discrete math, and then linear algebra. Soup. All right, so that's the lower division. You do that in your first 1.5 years. Then we have a pretty deep upper div of tons of classes you can take. You will not take all of them, but you will take many in each of these areas, right? So you have a chance to get a pretty broad view of computing, and you can customize what aspects of computing you want to go deeper on. There are a few additional requirements, which I'm not going to talk through here. The breadth requirements, which maybe I'll briefly highlight, we are continuing with the LNS breadth requirements from before. So CDSS has adopted a campus-wide breadth system, which basically sets, I think, 7 areas that you explore for breadth, and you can pick from a large number of classes in each of those areas to meet that breadth requirement. This is something that's established across all of campus. It's something that will also be updated in the next few years to improve the listings. So it's something that's pretty easy for people to accomplish, I guess. And we have essential skills, which again align to the most part with what was in LNS before. The one big change is we've removed foreign language, which is a bit weird. And instead we have 3 essential skills. One in computing, which is pretty easy to meet as a computer science student. One in inferential or statistical reasoning, which builds on a statistics curriculum, gives you a better understanding of working with data. And then a third one, dealing with ethics and society and the role of computing in ethics and society. So very aligned with the principles of CDSS itself. All right, so let's talk through the lower division. So 61A is the first class you take. This will be a big class. A lot of campus gets involved in this class. It's open to all of campus. It's not easy, but it's intended to get you going with programming, get you going with basic ideas in computer science. Then 61B brings in data structures, a little harder, building on what we did in 61A. Then around this time, you'll also probably take CS 70. This is a discrete math, probability, and a little bit of algorithms. So getting into kind of the more theoretical aspects of computer science. It will help you in your upper division classes. And as I said earlier, 61C touches on the machine structures themselves. So more understanding the basic principles of the hardware itself when it comes to computing. And this is important because computing today often takes advantage of advances in hardware. So you need to know about this stuff to be a fully versed computer scientist. We have some math requirements. You take math 1A, 1B, so you get calculus, which you use a lot in AI, so it's a good thing to have. And then some linear algebra. And we have a couple ways to achieve that using either math courses or an exciting set of classes, the E16A-B series that looks at signals and circuits, but through the lens of linear algebra. Okay. Courses. Upper div. Yeah, I can't go through this slide. There's so many options. It changes over time depending on what faculty want to teach and what's available. But we have classes on everything from user interface design, security, networking, distributed systems, algorithms. This one's algorithms taught very often. Compilers, operating systems or core systems, computer graphics, database design. I've taught that one. Complexity, combinatorics, quantum info science. So we have a lot of interest in quantum computing now at Berkeley, so you can take some quantum computing classes. They're hard. There's some technical electives that you can take in other areas, and you need to do that to finish your program. And there's a broad set of areas where you could do additional technical electives. And we have a lot of people take electives in business, econ, other sciences, maybe increasingly cognitive sciences, psychology as AI emerges. So a lot of opportunities to take technical electives elsewhere. All right, so that's kind of what your curriculum looks like. You need to take 24 units with 20 units from the EECS pool. That's from this side over here. And your classes are around 3 to 4 units per class, 4 for the technical electives. Yeah. Okay. Talk a little bit about space. Space changes in how you use it. I see undergrads, we have amazing lab space where you can work in big communities around desktops. But I often see undergrads pull out their laptops and hang out in hallways and build and kind of stand up pop-up spaces to do their homework or to work on research. So a lot of opportunities to collaborate around spaces. We have purpose-built spaces in Soda Hall. We have labs for building stuff, which maybe I can show here. Yeah, so you have some collaborative environment labs, the Jacobs School of Design, places where you can do fabrication, build things, a lot of research environments. Our courses have a project-based element to them, especially the upper div design courses. So you will work in teams, and you will do projects. And one thing we've been trying to do to improve community at Berkeley is starting to randomize those teams, because you need to build a community, and it can't just be your friends. You need to build a bigger community. Okay. Talk about culture now. First, teaching. So as I said earlier, I am a research faculty. That is to say, I do research. But I am also teaching. Over 93% of the courses are taught by regular faculty. So we teach the classes. We don't outsource that. Occasionally, we'll have external instructors for certain things that maybe an expert who's building database systems in the industry will come in and help teach a database class with us. Okay? So we sometimes have external instructors, but for the most part, it's us, not our grad students, us teaching the classes. We develop new courses. And I've developed new courses. Sometimes it's a mistake to make a new course. It's a lot of work. But a lot of the courses you will encounter, some of the courses you'll encounter will be new. They'll be buggy, but they'll be fun. The faculty care a lot about the courses they develop. Professors teach both graduate and undergraduate courses, and you have a chance to potentially get involved in some of the graduate courses as well, depending on the course. And student evaluations are part of our tenure cases. To get tenure at Berkeley, it is not enough to write amazing papers and get amazing awards. You have to teach classes, and you have to teach them well. And we know because we track it. So we actually maintain scores for all of our faculty, and in the public, you can see how people teach. These are my teaching scores. I am doing well, except for right here. There's a little bit of a glitch there. It was a graduate seminar I taught, and I was told it was too easy. Really? It was like 5, it's a graduate seminar, so only 5 grad students filled it out, and like 1 must have said meh. So anyways, got a low score on that one. But otherwise, yeah, generally faculty have good scores. Not all faculty, we're working on some faculty, but in general, people who are teaching these classes are putting a lot of energy into that teaching. Some faculty have gone so far as to win the Distinguished Teaching Award, which is across all of campus. And EECS is very good at this. We have many people who've already won the award. Someday me, someday. Yeah, not there yet. Yeah. So we pride ourselves in teaching. We have new faculty. 100 faculty is a lot of faculty. Faculty are retiring constantly, 5 to 10 retiring a year, let's say 5. Bring in some new faculty. Last year, this is the faculty we recruited, some of which have been at other schools, like Matei was previously at MIT. Stanford is now faculty here again, back at Berkeley. He was a grad student at Berkeley previously. So we have new faculty in new areas. As we grow areas, new faculty will come in. They will likely build new courses. Those courses might be really exciting. They might be a little bit messy, but you have a chance to see cutting-edge research in a classroom environment. Faculty-student interaction. You should do this. You must interact with faculty. That's an important part of Berkeley life. One way to really do it is research. If you come to Berkeley, you should be involved in research. It is a great chance to learn about the world. I said earlier, build things. You build things in research. You can grow your GitHub stars. You can build blogs that people, or write blogs that people read about the research you're doing. So not only are you actually advancing the research, you will also be advancing yourself. So research is really exciting. It's a great way to interact with faculty. Weekly office hours. I run weekly office hours. They're on my website. You can stop by. People do. They come to my office hours. Often they ask, Joey, what should I do with my job or my career planning? They don't always come in about classes, so office hours are open to whatever you want to talk about. So weekly office hours is a great chance to interact with faculty, about classes if you want, but also about your careers. Faculty advising. So we have every semester faculty advising. You can sign up to meet with faculty, either in group sessions or one-on-one. And like my office hours, you can come in and talk about your career path, what classes to take. If I want to study AI as it applies to chemistry, what should I do? If I want to get into grad school, what should I do? Great chance to work with faculty in that environment as well. We have faculty-student lunch meetings monthly. And then we have undergrad social hours, which faculty try to attend as well. So interaction with faculty in those cases as well. So a lot of opportunities to interact with faculty outside of the big classroom. We have a lot of staff to help students. Navigating Berkeley is complicated. Even for the faculty, I don't know the answers to many of these questions. We have a really strong team of directors and advising staff that help students through the program and help faculty advising students through the program. Okay? And you meet with these people ideally once a semester as well to guide you through that decision process. You might have figured things out, maybe you don't need to meet with them, but you have that opportunity. Okay? And that's critical. All right, so we want to support our students to succeed. We have tutoring. So when you're struggling in classes, we have multiple mechanisms in place. In fact, for my big data science class, we have a whole tutoring system that we're tracking students to make sure that we're giving them the support they need. And when students aren't doing well, we try to encourage them into that system and try to give them the support they need to do better. I already discussed advising, so a lot of opportunities to get advice from faculty. And then we have different programs for mentoring students as well, run by various clubs. So a lot of support structures there. There are so many student organizations at Berkeley, it's kind of crazy. And I've interacted with quite a few of these. These programs are things you can join to help your colleagues, to help other students, and also to get help yourself. I don't have a slide on this, but one thing that I think is amazing about Berkeley from the undergraduate student perspective is teaching. A lot of the big classes have undergrad TAs, and they are far better than my graduate student TAs because they care. They just learn the material and know it well, and they'll put the time in to help students to get through stuff. And they also are involved in tutoring activities, and they often join these organizations to help students as well. So a lot of opportunity to both be supported and to support your colleagues. It's a great way to learn. So I got this question recently in a EECS panel, and I think it's important to think through. Especially for those of you who are pursuing a profession where it's constantly changing. So I was asked, how do I study computer science when the field is constantly changing? And the answer to this question sort of leans on what Berkeley is. This is my answer. At UC Berkeley, you will learn about current trends in technology, how the field's evolving. You will also learn fundamental ideas. So you'll take upper division classes where we'll teach you details of how stochastic gradient descent works, how we use it to optimize something like ChatGPT. We'll also talk about how to implement something like ChatGPT using the technologies that we have today. And the idea is that, when you graduate, those technologies might be different, but you'll have the fundamentals. And having worked with those now, you'll understand how the field's evolving. Right? So exposure to both current trends and fundamental ideas. But maybe more critically, you will learn how to learn. And I can say this with confidence. The most important thing I learned as an undergrad was how to learn, and how to learn quickly when everything is a mess. Caltech is a great place. I love Caltech, but things were messy. Berkeley is a great place. I think we're a little less messy, but things will be tricky. You will encounter hard problems. In new classes, you will find assignments that don't actually have a correct answer. It's okay. Part of the process here is learning how to learn, learning how to get help when you need help, learning how to read stuff that's well-structured and stuff that's not so well-structured, how to learn in different environments and from different people. Right? Not everyone's going to teach the same. You will work with TAs, with graduate students, and even undergrads that will teach you differently. And learning how to learn in all these contexts is critical to working in a field that is constantly changing. And the last and maybe most important thing to think about when you're choosing where to go is your community. Because the community you get here will be the community you will have the rest of your life. And one of the things that I like about Berkeley is we have a very diverse community. The class we build, this new class of 150 students, we put a lot of thought into making sure that we had a diverse set of perspectives, and that here at Berkeley, that community is also supported by a much bigger diverse community, not just in engineering and in science, but in the humanities and other areas across campus. Okay? So community is critical. All right, so I'm going to briefly outline some opportunities ahead, and then I want to take some maybe the last 15-ish minutes for questions. All right. This came up in the previous session as well. Entrepreneurship is big at Berkeley. We have a weird amount of connection to VC groups and a large number of startups that have come from Berkeley. We have a fairly number of successful IPOs. There's Databricks is like on its way. It's a very, very successful AI company out of my previous lab. In fact, a couple of these are from previous labs. There's my company right there, another company on computing on encrypted data from previous lab. Some of these have been acquired. Some are pretty big. Yeah, and this is just a sample of some of the recent companies from Berkeley. So a lot of entrepreneurship, and most of these companies are being led by the graduate students or students involved in that work. Right? Faculty are involved as well, but these are often graduate student-led efforts. We also have our own on-campus VC firm, the House Fund, which I find undergrads are involved in actually the VC side of things and also in being invested in. It's kind of neat. So you should check out the House Fund. Most of the startups that come from campus also try to connect to that fund as a way to give back to the community. Right? So you get a chance to work on entrepreneurship. And we have other programs like the Excel Scholars Program, there to support people in launching startups from campus. So entrepreneurship is definitely an option here. We have incubator spaces. I talked about space enough already, but there's a lot of opportunities to take advantage of the space on campus to build things. And Citrus Lab in particular has a nice invention lab. I already mentioned Jacobs Institute for Design Innovation, another giant working space to fabricate technologies, work with people in design. And I keep saying this, but just one more time, undergraduate research is critical, an enormous opportunity for you. You get to participate in advanced research. You get to build next generation technology, and I'm not joking. My undergrads come to my lab and are building key parts of software. They're getting huge Twitter followings for their big open source projects. They will probably join startups from those projects as well. So getting involved in research could be a path to entrepreneurship as well. And you get to collaborate with faculty and graduate students and see if a PhD program is the right thing for you. Many undergrads go on to do PhDs or join startups launched out of the research they were doing. Okay. We have a lot of partnerships of career programs to bring people to campus. And in many cases, these people want to come to campus because they know that the best CS people in the world are here. So they pay money, actually try to recruit from us. And there are a lot of them. So the career fairs here are very, very active. Yep. I think I have how students do. Oh, the honors program I briefly want to mention. So we have an EECS honor program that's open to CS and EECS. So this is a chance to get a little bit of an enhanced educational experience, so more depth. So do additional research is required through this program. More breadth. So you do additional courses strictly outside of CS and EECS. Students typically enter after their third year, and you can talk to advising about that process. And there are a lot of benefits. Again, faculty advising, research experience, an official note of honors degree on your transcript. Fifth-year master's program, another key highlight of our program here. So those who, in their junior year, who are like, I want to do a master's, have an option to start getting involved in research, ideally in their junior year. And then in their senior year, they apply for the fifth-year master's, which means they stay one more year to finish up that research. And I have a lot of these students actually in my group. They're great because they go on to do really exciting research. When they finish that master's in just 1 year, they then graduate with a master's in their fifth year at Berkeley. So it's a great way to do a master's quickly, and there's a lot of interest these days in getting a master's degree. So master's degree and essentially in 1 year. Though you do need to start thinking about research in your junior year. All right, so what do you do with the degree? Change the world. I was not joking earlier. It is our responsibility to solve a lot of problems that face mankind. We should work on those problems. So when you graduate from here, you should use your skills to change the world, and we want to make sure that you are set up to do that. Some of you will like to get a job. CS grad salaries on average are apparently $120,000 US dollars. The students in my group are doing better than that, which is terrifying, but yeah, so you can get pretty good jobs, especially if you're working in AI. I won't say, but their numbers are, I need to get paid better. Okay. You can go on to graduate school, study, graduate professional school, maybe in engineering and computer science, or maybe in other areas, right? You build those basic reasoning skills that are critical no matter where you decide to go afterwards. And as I said earlier, a lot of people will go into entrepreneurship, either starting companies or joining startups that are coming out of Berkeley or other Bay Area spaces. We have a very strong alumni reputation, and I think this is true. And I've talked to companies I've worked with, Berkeley alumni. They're very, these words are perfect, self-starters. They go-get-it attitude, and they can get it done. They're not used to they don't come in like, oh, you're going to help me do this stuff. I'm going to figure it out. And that is a good skill to have, right? Very strong student. Street smarts, I like that. Yeah, street smarts. So just some examples. And this is just random cherry picking. You should check out this list. It's crazy. So we have a lot of distinguished alumni. Some that you might have heard of. So Paul Debevec got an Academy Award, I think fairly recently. Works in computer graphics. Director of Production and Innovative Research at Netflix, doing really cool stuff. Did his PhD in 1996. Yoki, co-founder of Google X and VP of Technology at Nest, did her BS here. Eric Schmidt is the executive chairman at Alphabet, PhD in 1982, alumni. And Shafi Gowasser is actually here now. She's at the Simons Institute, Turing Award winner. Did her PhD and her MS at Berkeley in the 80s. There's just a few. There are many. There's probably one more you might have heard of. Steve Wozniak, also bachelor's degree, 1986. Yeah. Steve's right here. This room he's standing in is called the Woz. It's one of our lecture halls in Soda Hall, named after Steve Wozniak. Yeah. So we've had some pretty successful, pretty influential, high-impact alum from Berkeley. All right, so I'm done. Summary. EECS is a vibrant and dynamic community. Again, community, important idea. We focus on leadership and research. Maintaining cutting-edge curriculum prepares our students to become leaders in their chosen profession. We want to have choice. We offer flexibility in what we do. You get to pick your curriculum. It emphasizes teamwork and research opportunities. Okay? As the keys to success in our program. All right, I've talked for a lot, longer than I wanted to. There is 15 minutes for questions. Let me do this. Are there questions on the poll that I should look at? Same set of questions. Let me just open up the poll and I'll try to go through your questions in the order that you have voted. Okay. How many CS freshmen will there be in the incoming class? 150.
That's with transfers.
Oh, sorry, without.
With just first years.
Just first year, sorry, without transfers, correct. AP course credits. What is the current answer for AP course credits?
For CS?
It's for CS.
For CS, we only take AP for math.
Yes. Okay, so CS only takes AP for math. I know some of the thought process behind it. The courses we take in computer science, those introductory courses, are very different than the AP curriculum. And if you've taken the AP classes, you'll do better. But they're still hard classes. So you'll still have to take the core computer science classes. Okay. Double major policy within the College of CDSS. So we allow for double majoring in CDSS. The details of double major really depend on the specific majors. So whether or not I can major in A and B depends on whether or not both A and B support double majoring. For the most part, I believe we support double majoring across the current programs in CDSS. But there may be more programs in the future where that may not be the case. Okay. All right, maybe I'll do one more and I'll just open up for the audience questions. What percentage of the current majors are women? Do you know the answer to that? Deb answered it? Okay, 1/3 CS majors are women, 1/2 data science and 1/2 stats. So it's 50-50 in stats and data science, and unfortunately 1/3 in CS. But I'm hoping that will change, especially as we've been able to change our enrollment process. All right, maybe I'll stop there. Questions from the audience? Yeah.
So, MS degree, right? For the MS, do we have to do BS or BA is okay?
BA is okay. So for the MS degree, the 5th-year master's, you can do that as a CS, CDSS CS student, like you all, or you could have come through the EECS path. EECS, you finish with a BS, and in CS, oh man, so many letters, in the CDSS CS degree, you graduate with a BA. And you might be like, well, isn't there science, computer science? Why is it a Bachelor of Arts? Turns out physics is also a BA on campus. Biology, technically also a science, also a BA. The actual letter doesn't matter that much. So we've stuck with BA. The big idea is that it's a broader study, not just a specific focus on science, but we have breadth requirements that go beyond just raw engineering. Yeah? All right, so for students that want to get involved in research in things like AI, what can you do to get started? One of the crazy, exciting, interesting things about AI today is that it's actually much more approachable than it has been in the past, in part because software abstractions have made it easier. Freshmen coming in can start to pick up those skills. In fact, after taking the 61 series, you have the basic Python skills to start building neural nets. And they're like hour-long tutorials that you could watch and start training networks yourself. So students can get involved in research. I will say that kind of first-year students, their biggest opportunity to get involved in research is helping these graduate students do things like visualize the results that they just built, run a set of experiments, which means writing scripts to launch those on the cloud, get GPUs, and do the actual experiment itself. Doing that, and then you go, you know what, your experiment's broken, but I will fix it, right? And then you start doing the research itself. Other questions? Yeah.
Can you get involved in research as a freshman?
Yeah, so can you get involved in research as a freshman, first year? In general, the answer is yes. Does it happen as often? Not as often, because you're going to take a lot of classes. Some freshmen have gotten involved in research. One of the freshmen is now a graduate student in my lab, so like that happens. It's not the common path. It's often more in your sophomore year, but you will have the basic skills, after your first semester to start potentially doing things in research. Often it's kind of helping others do the core research, but again, that's a path to doing the research itself. Other questions? Are there classes in AI and ML that are exclusive to CS or EECS? And in terms of enrollment, EECS and CS have priority in those classes. There are some classes where there's priority also allocated for the data science program, for the data science major. So if you are in CS or ECS, you have sort of the highest privilege in getting into these classes, which is good. And again, as we've shrunk the major down, it should make it easier and easier to find slots in these classes. Yeah.
I heard that sometimes before it's difficult to choose the courses to register the course. Will it still be the case?
Historically, we've had trouble with enrollment in classes because the major is so big and so many people want to get in, and running big classes well is hard. And so it could have been hard to get in classes. Again, the whole intent of this enormous reduction in people admitted to CS is to try to alleviate that. I don't know what the current state of people enrolling. How is it going? Are people getting into classes? Overall, yeah. So there are some classes like 162 that are potentially smaller. The AI classes have been pretty good. CS 188, for example, the core AI class, is generally pretty large and can accommodate the students that want to take it. CS 189 is the more advanced technically introductory machine learning class. That has historically been a little tough to get into, though I think now with the kind of shrinking of the major, that should be easier. There's CS 182, which is deep learning, which I will hopefully start teaching in a year or so, and that will potentially get bigger. So there should be lots of opportunities to do AI-related work.
Yeah, this is a follow-up question. So will the CS student have a priority to register to CS courses?
Yeah, so CS students have priority, correct. And again, it's a unique priority. So CS students and EECS students are equal on that. You know, they get to register in the CS, EECS courses first. With the small exception of some data science classes where they're also lifted to that priority. Yeah. Yes?
Will the shrinking of the major also affect the lower division class sizes as well?
So the lower division class sizes we're trying to keep as open as possible. The 61A, 61B series are important to all of campus, so we want to allow people to get into those classes. So we probably won't shrink those, but they are so well organized at this point, and they have so much staff structure and support that it seems to work at scale. In fact, we're experimenting with new programs where we actually have no TA in a discussion session, but we basically sign out assignments and have a TA that travels between discussion sections to see if that helps with students. And some students actually like as they build their own community, some don't, so we're trying different models for how to support these big classes. Yeah.
So you reduced the CS size, but you did not reduce the EECS size. So overall, and you said that EECS and CS are the same.
EECS got smaller, I think, right? Where EECS enrollment is. So we controlled enrollment to EECS through COE, right? The same, okay, yeah. So EECS wasn't as big, was the problem before. So EECS was 250? Yeah, 300, yeah. So EECS is 300 and CS got to 1,000. And one of the challenges for us is it's hard to manage students coming in. So we used the grade GPA cutoff, which created a bad atmosphere at Berkeley. So we've gotten rid of that. And now we can directly admit people into the program itself. So that 1,000 goes down to 150, which is a big, big shift.
150 in the third year?
One more time?
The class size goes to 150?
So we admit 150 students per year, roughly, into the CS program.
What is the class size in the third year?
What is the class size in the third year? I don't know.
So we were saying a range for upper divisions, like anywhere from 100 to maybe like 700.
100 to 700. It's complicated. We also have transfer students that come in on their second and third year, or sorry, third and fourth year, to give you the exact size. And also, again, it's 2 years into this program where we've shrunk things down, so we don't know what the steady state will be. Yeah. I got it. So CDS will have the campus reading composition skills. So campus has, so you know, we have several layers of requirements. So there's campus level requirements, and then there's college level requirements, and then there's major level requirements. So campus level requirements, I believe, has the reading and comprehension. Yeah. Yep. And one more. I forget what the other. American Studies. American culture, yeah. And then college has those three core requirements I mentioned earlier, plus the breadth requirements, and then the major will have additional requirements you need to complete. They layer. And then you asked about internships. I know sophomore, junior, definitely a lot of internships. I don't know about freshman, first year. Sometimes. Yeah. Yeah, so some companies will have programs. Some will stay on for research if you get involved in research in your first year. So, okay. Questions about cybersecurity. What do you want to know? What do people want to know about cybersecurity? Any questions? Yeah. So CS 161 is our security class, taught by Raluca, my colleague. It is open. Yeah, you should be able to get into it. It's an undergrad class. It's pretty popular. Yep.
How can you take graduate courses in undergrad?
So graduate courses are tricky. When I teach graduate seminars, I try to open up to undergrads. It depends on space, how much room I have in my room. Some faculty will have undergrads in them, some won't. One of the best ways to get involved in a graduate class is go, hey Joey, I want to work with you, get involved in my research, and are you teaching a graduate class next semester? Can I take it? And then usually students involved in the research can get some priority in some of the graduate classes. Some of the graduate classes, like 189, 289, basically take the undergrad curriculum and add stuff to it. So you might have a few graduate students in the 189 class, but they're in a different, they'll use the lecture, but they're going through a different grading process. So we actually have some overlap between as I was saying, 189, some of these intro to machine learning classes are actually quite challenging because the graduate students will also be learning in those classes. So, yep. So how would I apply computer science skills to public policy? I'm glad you asked that. It's important. We should start doing a lot more of that. One of the things that has already come up on campus is what to do with generative AI, and there's a lot of excitement about how to regulate it. And the people who are excited about how to regulate it don't maybe understand the full possibilities of what you can and cannot regulate. And so getting involved in some of these big discussions that are shaping society with the skills that you build here is important. And we have programs through the collaborations with the law school to do these sorts of things. How competitive are the CS clubs at Berkeley? I don't know how to answer that. They're competitive, I'm told.
It's something that I've actually brought up with EECS.
Okay.
Leadership that I'm hoping the new colleagues.
All right, so I've actually heard about this. So some of the clubs at Berkeley are very competitive. The AI machine learning club, you got to be very good at machine learning to get in that club. Clubs are important. It's a part of the community. It's something that we are looking at to try to make it a little bit less competitive. Again, this idea of not having these GPA cutoffs and having this race to be the very highest person above that cutoff, I'm hoping will change some of the culture in the EECS and CS divisions, majors, so that we don't have such a competitive atmosphere. Yeah?
You mentioned the categories for upper division classes. Do students typically end up concentrating in one or two, like over?
Do students concentrate in one or two categories for upper div?
Yeah,
They can. I've seen a mix. So students that I've worked with have done a broad spectrum. I've seen some that's like, I'm doing AI, and just keep doing all the AI stuff. It's sort of up to you. I encourage students to get a little broader spectrum just because I do AI research, but I also build large-scale systems to do that AI research. And so I end up covering two areas, and now I'm making them secure, so I'm also learning cryptographic stuff. So research and computing is an evolving field. Having a breadth of knowledge is often useful. Yeah, in the back.
What kind of
Resources
resources do you have for women in computer science?
for women in computer science. Let me actually bring up the slide. We have quite a few organizations. There is a table in SOTA right now for this. Yeah, so if you go to SOTA, we have a table for it. Let me see if I can bring this up. So we have a few. I've worked with a couple, given talks and joined their meetings. So we have